We have this model N of S which represents the number of cars that can pass a given spot per minute, and we have to answer the question at what speed the greatest number of cars travel safely on the road. So basically we have to apply the calculus first derivative test to determine the speed at which the greatest number of cars can travel safely on the road. So let me use the model N of S. I copy this model N of S. This is equal to 85S divided by 17 plus 17 times of S by 19 quantity squared. So before I do the differentiation, I'm going to simplify this. So I put the numerator as it is, and you can see that we can factor 17 from the denominator terms. So I factor 17. When I do that, I get 1 plus S by 19 quantity squared inside the brackets. So we can cancel this 85 with the 17 as 5 times. So therefore this can be written as 5s divided by 1 plus this inside part s by 19 quantity square is equal to, when you square it up, you get s squared by 19 squared is 361. We can also further simplify this. So this is equal to 5s divided by the denominator we have 361 plus s squared over 361, which means this 361 will go to the numerator. It will get multiplied with numerator. So let me write down here. So this is equal to 5s times of 361 divided by 361 plus s squared. And this is equal to 5 times of 361 is 1805 s divided by 361 plus s squared. So this is the model. We have simplified the model to this representation. Now we have to apply the calculus first derivative to find the maximum number of cars and the corresponding speed. So this usually happens at n prime of s equal to 0. That is, when the first derivative is equal to 0, at that point the maximum value happens. So first let's find the first derivative of n of s by differentiating both sides with respect to s. When we do that, we get left side equal to n prime of s equal to differentiate this right side, we have to use the quotient rule. So remember that quotient rule is, suppose if we have a function p of x divided by q of x, this is equal to q of x multiplied by the derivative of p of x minus, take the p of x and multiply with the derivative of the denominator q of x over the quantity square of the denominator term. So this is the quotient rule. Let's apply this quotient rule to differentiate this right side. So I take this denominator term 361 plus s squared multiplied with the differentiation of the numerator term, that is 1805s, and when you differentiate with respect to x, we get 1805 times our differentiation of s with respect to s is 1, so it's just simply 1805 minus, you consider the first term, that is the numerator term, and multiply with the differentiation of the denominator term, that is 361 plus s squared. We have to differentiate with respect to s, and when you do that, 361 is a constant, so this becomes 0, and differentiation of s squared is 2s over the 361 plus s squared quantity square. Now I'm going to factor 1805, as I can see that 1805 is there in both terms. It's a product term in both terms like this. So you can factor this 1805, and when I do that, the first term I'll be left with 361 plus s squared, and in the second term I'll be left with 2s squared. So it is basically negative 2s squared, which means this s squared minus 2s squared is negative s squared. I can write down this as s squared minus 2s squared is negative s squared. So I have 361 minus of s squared inside this bracket. We'll move this. divided by 361 plus s squared quantity square. So now we have to set up n prime of s equal to 0, which means we can plug in n prime of s equal to 0. So this happens only when the numerator term is 0. So what we do is we take the numerator term and set it up equal to 0. 361 minus of s squared equal to 0. We divide both sides by 1805. When you do that, we simply get 361 minus of s squared equal to 0. We can now solve for s from this. So s squared is equal to 361, and this gives s equal to plus minus square root of 361. Square root of 361 is basically 19. We just ignore the negative 19, so because the speed may not be negative, so we just keep the speed as it is. Now we have to determine if this speed gives the maximum number of cars. That is, at this speed that we have maximum number of cars. So what we can do is either we can check this using the first derivative, the continuation of the first derivative, or we can use the second derivative. So here I'm going to use the first derivative sign chart. So for that, what I do is I create a number line. So at this point, I know that either it can be maximum or minimum. So I considered 2 points, that is 1 point less than that and 1 point greater than 19, which means I have to plug in s equal to 18 and check whether I get positive or negative sign for this is a sign chart for n prime of s. And similarly, I have to plug in s equal to 20 into the n prime of s and see whether I get positive or negative sign. So let's do that. So for that, I'm going to use this, consider this expression. This is the expression for n prime of s. So let me copy that here. We have n prime of s is equal to 1805 multiplied with 361 minus of s squared divided by 361 plus s squared quantity square. Now for the sign chart, we just have to focus only this, because this term is always going to be positive irrespective of whatever the value of s we plug in. This term is positive, so we plug in the value of s equal to 18 or 20 into only this one, that is 361 minus of s squared. When you plug in 18 into this one, so this is basically 19 squared minus of 18 squared. This will be positive, that is greater than 0. That is at 18, we can see that it is positive, so I put positive here. And when I plug in 20, this will be 19 squared minus of 20 squared. This will be negative because 20 squared is larger than 19 squared. So therefore this side, this will be negative, which means we can create the sign chart as like this. The slope of this function, that is n of s, is increasing, and at the point s equal to 19, it just decreases or it becomes 0, and then it further decreases. So this clearly confirms that at s equal to 19, there are maximum number of cars that travel at this speed. So therefore the final value that we confirm is s equal to 19. The speed at which the car has to travel is 19, so that maximum number of cars can travel at that spot.